Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. We are in week number 44. That means that when we're done with this week, this lesson, we will only have 8 more lessons to go. Hard to believe. But don't worry, if you're hungry for more information, I'm happy to answer questions. I may do additions if there's requests for those. So just let me know how it's going and what I can tell you that I may not have told you so far. So what are we talking about this week? This week we are talking about Mongo. That is a NoSQL type of database. So we talked about moving the data out of the global data in the Flask server into a database. We talked about how to do that with SQL data. Last lesson and this lesson or this week, we're going to be using Mongo. Now the nice thing about Mongo is that it is way more flexible and hence it's a lot easier to use in certain ways than SQL data is. So we will be finding out how nice that is, and we will be seeing how we gather the data. We'll be seeing what it looks like when it's stored in the database. This may look really ugly to you, but the good news is that the data here is all in JSON format. Good thing we learned about JSON, so we know what that is. There's going to be key and value pairs. Here's my name. Here's the actual value. Here's the key of type. And this is the value that it's ICMP. These are services that I'm looking at actually. So this is what this is going to be about. I will be showing you the code and we'll be looking at different aspects of the code and how easy it is to set it up. In fact, we don't even have to set it up. We'll be looking at this DB API thing, which is what shields our Quokka server code from the details of the database type in the backend. We'll be seeing how easy it is to reference data in the database. You can do finds, you can do inserts and all things of that nature. And then we'll look at how difficult it is. Not really difficult at all. In order to set up your database, you just need to make sure that it's there. And then you create this thing called DB and you're good to go. So that's what we'll be talking about. Hopefully this will make sense to you. If there's things that you have questions on, feel free to let me know. Communicate with me if this is working for you. If there's something that I missed, let me know as well, and I'll be happy to figure it out and add it for you. Thanks. Let's get started. Okay, so let's get started talking about using Mongo as our NoSQL type of database. Before we do that, let's remind ourselves where we came from. Remember, we have this application that has these individual little applications, these monitors that are doing stuff for host devices and services, and we have display applications as well that are throwing stuff up on the screen like you see behind this screen. And then we have this Flask server that I'm calling the Quokka server, and originally we were storing the data in memory in this manner, and what we said was we wanted to move that out to a database. So in the last lesson, we looked at moving it to an SQL database. Now I started with SQL partly because that's what I've used the most in my days of writing software over the decades, but also because it seems to be one of the more popular ways of doing things. But more recently, doing things in a NoSQL manner seems to become in gaining popularity. And so that's what we're doing at this point in time. And maybe when you see it, you'll say, oh, I wish Chuck had started with this because it's easier. You will see that dealing with Mongo is going to be a whole lot easier than it was dealing with SQL, even though we had SQL Alchemy to make our lives very easy. So let's remind ourselves quickly, why are we doing a database? They give you scalability. You can grow it as big as you want. They give you performance for doing queries and doing things like filtering and ordering, stuff like that. Databases are reliable. That is, they're not going to end up in a bad state. You can do things concurrently. Lots of different threads can access the database at the same time, and it will be handled appropriately. And this acronym ACID, you can look those up. That's kind of a restatement of the things that I mentioned using different terms right there. Now we do want to spend just a minute looking at this because what we're going to be doing is we're talking about Mongo, which falls into this category, this NoSQL that, as we talked about, actually stands for not only SQL, but you'll see it's very much fundamentally different than SQL. In SQL, if you remember from the last lesson, if you made it through, we had to define everything. So you see everything is predefined. The set of tables, every table is predefined, and every column in every table is predefined. So I had to define classes for each one of those, and I had to go through a whole bunch of setup at the very beginning. Not so with your NoSQL type of database. With Mongo, it's not relational, it's not structured, it's flexible, meaning you don't have to define the schema beforehand. You have collections instead of tables, and you can create them on the fly if you so choose. The columns, you don't have columns, you just have JSON defined data within each item inside your collection. A collection is like a table, a document is like a row, and you separate things. Instead of having fixed columns, you have JSON stuff. So as you know, with JSON, you can have missing items in your JSON object. Not missing, but just not present. You can have more things, you can add new things. It makes it for a very flexible way of doing things, and that's what we're going to get to appreciate. So that's what we're talking about. Now let's look a little bit at the outcome of all of this. So there's a whole lot of stuff going on the screen here. Down here, you see I have my services. I'm monitoring them. If you recall, I'm using this cyan color to represent the fact that it's not meeting its SLA requirements. So my requirement, I think, is individual for each one of these, but I think for David Bombal and for my gateway that I'm pinging, they're both 1 second. And so this one here you see is 1.01, so it went over it by a little bit. Now my other laptop that I have Ubuntu running on, I'm going to close that, and you will see it go away probably in 2 more cycles, maybe the next cycle, I'm not sure. It will take a while for it to time out, so we can keep our eye on that. Here is my hosts table. In my hosts table, you can see that the things, and it's true down here as well, things that are the same are this green, and the things that have changed are the bright green. And bright green typically means that it has, the last herd has been updated. So yeah, you'll see that turn to bright green. We can look down here again. I did close my laptop. You can see that it has gone red, so its availability has turned to false right there. And now you can see we're beginning to go through the process of pinging all of these hosts, and they're getting updated a little bit at a time. And you can see the ones that I'm no longer able to communicate with. And then up here I have devices. So with devices, I'm actually using Napalm to communicate with these devices. So I'm doing an SSH connection to them. These both happen to be using SSH to connect to the devices. Oh, and here's something interesting that I added. I added compliance. So I'm reading in compliance information, and if the OS version is not current with what I believe this model of device should be, then I print it in red, just that item in red. So you can see that I added a little bit of intelligence there. Oh, and sorry, I forgot. Another thing that I added that we saw earlier, but I didn't have with the SQL, is I added yet another monitoring application. So I have a port scan monitoring application. So it's going out and it's actually scanning these devices independent of the polling. When we did this before, I would poll and then I would scan, and I would poll and I would scan. Here I've got 2 separate applications going, and one of them is doing scanning and the other one is doing polling. If I go back and look at this picture, what do I mean by that? What I mean is that there's another one of these that would be called host_scan. In fact, that's what I called it, and it's yet another application that I've got running out here. I should do a picture for that, but that is what I'm doing. In fact, I'm going to do that right now. Hang on a second. Okay, there we go. So we've got host scan going on at the same time that host monitor is going on. And the thing that's interesting here is that both of these are going to be updating that host table. If this was stored in memory, that could be a problem. But because I'm storing it in the database is able to handle concurrency without any issues. So we're good to go there. So this is what's going on in this particular output that you see. I've got the output here that's all stored in the database. So it's in the same database table. The difference is that these two different applications are actually writing information. Host scan is just updating the scan information. Host monitor is updating the other stuff. And so that's that. And this was the actual, this information that we have here is new. Okay, so that's what we've got going. And let's begin to look down at the code to see what it actually looks like. Okay, so let's look at the code now. If I know you, you're going to want to be looking right here at this code or at this code, and I want you to not do that. I want your attention focused over here on what I'm looking at in the middle of the screen right here, okay? Maybe that's confusing. I'm going to put it back, but I just want you to get the idea that I want you to be thinking about what I'm about to talk about here. This was our implementation when we used SQL Alchemy. Remember, all of these files were inside this one directory. And so we had all of the DB APIs, DB classes, and then we had device display, device monitor, host monitor, service display, service monitor, this service monitor, object-oriented stuff. It was all together. Now look at our Mongo implementation. I only have these 3 files. Why do I only have these 3 files? It's because I went ahead and moved all of these files into this separate package or directory, whatever I wanted to have it. It has to be actually a package in order for me to reference it. So inside of this package called common, and while I didn't make the change for the SQL Quokka, SQL Alchemy version, because I'd already implemented it here and we were trying to keep things simple, for Mongo, I went ahead and separated out the stuff that is unique to the different type of database, Mongo versus SQL, and the stuff that is common. As you can see, this is all common files and code. If I was to show it to you pictorially and we were to look at this, what I'm saying is that everything that you see out here, this and this and this and this and this and this and this, those are all independent of what we do at the back end. And this is a sign of how you'd want to develop things in a modular fashion. We used to call it modular in the old days, where you have different responsibilities for different application components and they would be independent of each other. So these are only what we would say loosely coupled. How do we loosely couple things? In the situation I'm discussing right now, they're loosely coupled because it goes through this REST API. That is one of the tremendous things about this. You want to change the backend database? Great. None of this other stuff, none of these things have to change at all. They stay exactly the same. You want to go from doing a database to doing it in memory again with some other type of locking that you want to do? We can do that. It doesn't matter because this REST API basically shields everything outside from what goes on inside. So you can change your database. You can do a whole lot of things. So that is something that I wanted to make sure that you were aware of. This is when you look at this code, if you go into my repository on GitHub and you look at the code and you go, wow, this is really hardly any stuff going on here. Well, that's because all of the other stuff that makes this wonderful stuff happen that you see right here, most of that stuff that you see, here's all of my monitoring. It's all running on its own, unchanged. Here's my display, which is unchanged. This display is unchanged. This display is unchanged. I'm going to say fundamentally unchanged because I did change it so that I could add in the port scan data on this one right here. So it's got port scan column that it's showing. And over here in my devices, I added some intelligence so that it was able to determine, okay, is this meeting the standards or not? And if it's not, then it highlights it red. I cannot recall actually if I did the SLA type stuff where I'm doing these in cyan in the last one. I think that I did. But anyway, you get the idea. This stuff did not have to change because of the database change. that we made, and that's because of the REST API that we implemented. So I want you to be well aware of that. Okay, so let's actually look down at the code now. Finally, I hear you saying, but wait, here's something. I just want to make sure that you understand this. The stuff that I just described and the picture that I showed you, these are really important. If you want to become more than just somebody who cranks out code, but somebody who understands the design of software, understanding this stuff is extremely critical. It's not that difficult. It's common sense. I think you'll agree that this is a good way to do things. You don't have to have degrees in computer science to understand that. It just kind of makes sense, and so everybody can benefit from that. So there, I'm on my soapbox telling you why that's important. Now let's look at the code. I'm going to make this smaller so we can look at these things side by side. What am I looking at? Let's look at the tab here. M05 Flask MongoDB. So that's in my Flask MongoDB. This one over here is M07B. Sorry, did I say M0? Let me start over. M07C Flask MongoDB is the folder that we're looking at there to look at my Quokka server. And over here, I'm looking back at the SQL Alchemy version, okay? So this over here is SQL Alchemy. This over here is my Mongo stuff, all right? So let's take a look at what we did with our SQL Alchemy. So here I have some stuff going on with my SQL Alchemy. Remember, I needed to do this extensions to get away from circular imports. Here's a bunch of initialization stuff that I had to do. So if I were to start really honestly, right about here, I'm having to do database type stuff. I'm having to import my database classes, and then I do this final create all. So that is what I'm having to do in order to get everything initialized appropriately. Is basically all of this stuff is necessary to set up my database. Plus, what I didn't show you is that this is actually, there's a lot of definition there, right? When I go down, and if we were to look at this, this was a whole lot of code that I had to write to define my structured database. Remember, SQL structured, I'm defining every single column that I'm going to have. Let's look at all the hard work that we have to do over here in Mongo. All right, this is just Flask. This is just Flask. What happened to all of my Mongo definition stuff? Remember this picture, and I just want to reiterate it. Sorry for going over it again and again. It's flexible. You kind of define things on the fly. You can do that with the JSON definition of your columns, so you don't have to do all that other stuff that we did before. I don't even have any DB classes. If we do go back here, one of the things that we had here, remember, was DB underscore classes. That's what we just looked at just a second ago over here before I got rid of it. Where are my DB classes over here? I don't have any. That's because all of the data is in this free form flexible JSON. Every row in a table is just a JSON document. And so to reiterate that, I'm going to pull up Mongo and show you what the two different things look like, SQL versus Mongo. All right, so what I'm going to do is I'm going to go into my Mongo CLI. So I do this, I go into my Mongo CLI. I'm not going to spend a bunch of time teaching you this. You can learn about it online. I'm going to say use Quokka DB, and I'm going to say show tables, and it's going to show me that I have devices and hosts and services. Now I'm going to go back to the command that shows me all of the hosts. The commands are quite different. They don't look like SQL. That's because they aren't SQL. It looks more like code. That's kind of the way that Mongo works. But let's look at my table with all of the rows in it. All right, you're looking at this and saying, whoa, that's kind of hard to read. You're absolutely correct. It's very hard to read for me as a human. But let's just look at this one line. What does this look like to you? I've got curly braces here. I've got quotes. This is my key, IP address, colon, value. So this looks like a Python dictionary, but because you know we're doing this using JSON, then you know that this is just JSON data. Every row in my table looks like JSON data, all right? And if I was to do this for devices, here's my devices, you would expect there to be 2 of these, and in fact there's 2. There's a lot of information in here, but that's one of my devices, and this is the other of my devices. So you can see there's information in here, but it's all in JSON format. So hopefully you'll understand me when I tell you now, and you have a better visual idea of what it means for this to be JSON data. Now let's look at SQL database. Okay, so I wanted to show you the data from SQLite that we created when we ran our little application before. SQLite is SQL data just like every other SQL database is, but unfortunately I don't have data in there, and I'm not at a situation where I want to run that again. So what I figured I would do is show you the data in Quokka itself, and the purpose is not to educate you on Quokka, but to give you an idea of the contrast and comparison between what we do with Mongo, or what the data is stored like in Mongo, versus what it's stored like in SQL. So I'm going to say PSQL Quokka. I'm now in my Quokka database, and if I say select star from host, that's the name of my table, is host. You can see everything is nicely formatted. I have my columns that are well named, and everything is in its place, and it's perfectly predefined and looks good, etc., etc., etc. Now, down here, it's a lot messier, right? If I do, here I'm running the same thing again. You can't tell that I did, but I just ran it again. The data is way less easy to read and understand for me as a human. However, let me tell you, it's way easier to deal with in the code. So I just want to make sure that you're aware of that. This is what the data actually looks like. It's going to be JSON data, and it will have all the same stuff. In fact, here, there's my IP address. You see that IP address up there. Down here, you can see I have something called a MAC address. That's the key and the value. And here, that's where I'm keeping that MAC address. Host name. Is there a host name? I don't have host name in Quokka. I have a name in Quokka, but it's effectively the same thing. I just called it something different. Last heard is the same as last heard. I have availability and response time that you can see up here as well. So this is an SQL database, and this is how stuff gets stored in Mongo. And you may or may not be comfortable with it, but I think when you see the code, you'll realize that it is easier to deal with. So now let's look back at the code. Okay, let's get back to comparing the code between our SQL Quokka server and our Mongo Quokka server. Remember, we have all of this extra stuff going on here for initialization of the database. No such thing over here on the Mongo side. But let's take a look here just so that we have an idea of what's going on between the two. These are the two pieces of code that handle the requests that come in. This is for the host request, this is for the host request. So let's look at this code right here. What do you notice when you look at this code versus the code over here? This is the SQL version. This over here is the Mongo version. If you look closely, I think you'll see that they're identical. In other words, what we end up doing is we call get all hosts if we're going to get the hosts, and we call set hosts if we're going to set the hosts. And if I go down to devices, we're going to see that it's the same thing, get all devices, set devices, and the same thing for services. So what does that mean? That means that this code right here, the code that actually does something, is identical in these two applications. So basically my SQL version is identical to my Mongo version. How did I achieve that? Well, the way that I achieved that, remember, is via these APIs that I created. Let me put them up here so that we can see. We have APIs that are called get all hosts, set hosts, get all devices and set device, get all services and set service, and I have the same thing over here. Now, this code doesn't have to change, but guess what? In this situation, I'm calling my DB APIs. Let's go and look at the code structure. I'm calling DB APIs from my Mongo package here. So my Mongo service is using these DB APIs. Over here in my SQL version, I have different DB APIs. So let's look at the difference between the two. So let's look at this DB APIs code, because that's the stuff that our Quokka server is eventually going to be calling. Get all hosts is part of DB APIs, and so is set host. So let's look at that. Now, if you recall, I have this code right here. This is my Mongo version of DB APIs. Over here, I have my SQL version using SQL Alchemy. You'll see that it's a little bit more complicated, but they're both fairly straightforward in what they do. But the Mongo one, of course, tends to be a lot simpler. I'm not having to deal with classes. I'm not doing commits and things of that nature. It does it all for me. So let's take a look at what it does. Here is get all hosts, and what's it going to do? Well, it's going to create this thing called hosts, which is going to be, you look at these curly braces and you say, well, that's looking quite dictionary-ish, and if you look on the inside, then you'll begin to realize, oh wow, that's a dictionary comprehension like we've gone over before. Basically, we're going to iterate through something, and for every host, we're going to have the key be the host name, and the value is going to be the host. But before I put the host in there, I'm going to do this remove internals. All remove internals does is it returns exactly the same thing that was passed to it, except it gets rid of all of the items that start with an underscore. And if we look at some of the code, some of the Mongo data actually, and you can see here underscore ID is the value that's in all of these particular documents inside the MongoDB table. It's really called a collection, but you can think of it however you like. But for every entry here, it's going to have something with an underscore ID in it. And we don't care about that, so we're getting rid of that. And that's all that this does. So you see remove internals. So basically it's going to be, host is going to be a collection of dictionary items, and every dictionary item is going to have a key of the host name and a value of the actual host. And it will just have removed that thing with an underscore. Now what about for setting hosts? Because that was a little bit more difficult over here. Not so much difficult, but we had to be careful not to overwrite stuff that we weren't really trying to overwrite. So if we were to go back and look at what it's like in the Mongo version, what do? Well, basically we get the existing host from the database. So we do db.host.find1. You see over here, we're doing db.host.find. That gets all of them. In this situation, I'm doing db.host.find1. That's getting just one. With find, I can pass in a search criteria if I want to, but I will be getting a bunch of them. In this situation, I've returned nothing. That's when I'm getting all of them. In this situation, I just want to find that one host that's being passed in. And so I create this search criteria dictionary, which has host name. And so it's going to look for the host name, and the value of the host name is going to be whatever is inside that host. And if it does not find the existing host, then all it's going to do is it's going to insert that host. So it's going to create a new document into the collection. Basically, that's like adding a row to a table, but it's going to add a new host to my list of hosts. And if it finds it, what it's going to do is it's going to update one. And which one is it going to update? We have to tell it which one to update. And then we need to tell it this command. This is just the PyMongo syntax. I need to say $set. That's telling PyMongo that we're going to do a set into that database in this particular collection, and it's going to set these host values. And what it's going to do is, if it's overwriting an existing item inside that JSON data, so if I go here, if it's overwriting something like the availability, if it already exists, then it will overwrite it. And if it doesn't have that value in the host that I'm given, then it won't change what was in there. So that is what it's going to do. It's going to find it, and then it's going to set whatever has been in my host. So if my host comes in and it's only set, let's say, the availability and the last heard, and leaves everything else the same, then only that will get updated. And that's how Mongo and PyMongo work. It's the same for services and for devices. And you can see it's a little bit different than what we did here. This is a little bit more databasey. I'm doing adds to the database, or I'm updating the object. I'm doing a commit in both of those situations. In this situation, all I'm doing is I am in my get all hosts, I'm just making this request here. In setting it, I'm either doing an insert to the database directly, or I'm doing an update directly, and that takes care of it. And that's how my DB APIs for my Mongo version of this works. And just to reiterate, once again, I know I've gone over this a lot, but it doesn't matter if my database here that we're looking at is SQL Alchemy or Mongo. This stuff out here remains the same. Now my Quokka server changed a little bit, but because I'm using, I could draw a layer here that says DB APIs. Because I'm using DB APIs, then my Quokka server, I minimize the changes that are required for that. And that's how we do Mongo. Okay, we've seen that DB API shields the Quokka server code from having to worry about the database. All the database stuff is in here, and we've looked at this code to see what it does in general, but I didn't go very deeply into all of these database calls that we're doing and what they mean and how they work, etc. So let's look at that. Here in get all hosts, we're doing something with this thing called DB. I can see that I'm importing that from extensions. We'll look at that in a second. Then I'm saying .hosts. I'm assuming by looking at that that is referring to what in SQL language we would call a table, but in NoSQL we call a collection. And then we're doing a find on that. And in a similar way, we do a find one. Here, we do either an insert one into that collection, or we're doing an update one. And so we can kind of get the general idea, but how is this actually working? Well, when did we set up the database? You recall, we didn't set up the database at all. With SQL, we had to do a bunch of setup and let it know all the classes, which referred to tables and all the columns, etc. We didn't do any of that. All that we have is this. And in fact, even in Quokka server, we're not importing anything from this extensions where we define the database. We are referring to it in this thing called DB APIs, which we've been looking at. So we are importing this thing called DB that, as you've seen, I've been using down here. We're importing that from extensions. Now, you remember we had extensions with SQL. Let's take a look and see what this is in the Mongo world. And what we can realize right now, and this is a little bit humorous, this took me to the wrong extensions.py. This is a PyCharm. I'm not sure if I would call it a PyCharm bug, but you notice it took me to M07B. That's not actually what I'm doing. I want to go to the extensions when M07C, because I was actually in DB APIs, as you see, in M07C. So here you go. If you end up in this situation, you may be, if you're going through here, just be aware that the fancy control B may take you to a place that you didn't actually want to go. So here's my SQL stuff, and you can see why I was surprised when I saw SQL Alchemy. I thought that there was definitely something wrong. And in fact, there is. What I wanted to go to was this extensions. This is the one that is actually the one that is being referred to here. And what does this look like? So here I am doing my PyMongo stuff. So I say from PyMongo, that's the package that I installed. I'm importing this thing called Mongo client. Now you are aware of in the fact that Python and in other programming languages, when we use capitals, then we're probably referring to a class definition, especially in Python, and that is exactly what we're doing here. Capital M tells you that this is going to be a class definition. And you won't be surprised then when we look at this and we see, okay, well, this is our instantiation or creation of an object out of that class. So we're creating a Mongo client. Now there's actually parameters that I can pass here. I can pass the actual host on which my Mongo is running, and I can pass the port to which we are going to connect. By default, it's going to use localhost and the port number, which I can't remember what exactly it is. You can look it up, but it's the default Mongo port number. And since I just installed Mongo, followed the instructions to get it up and running and have it boot every time I boot my system, then it's just using all the defaults, so I don't have to do anything more than that. So now I have my Mongo client, and here's something interesting. All I need to do in order to link my client to my actual database is provide the name of the database that I called it. This is actually the database name, and you see this a lot in the way that Mongo works. Here I'm doing dot and then giving it the database name. Down here I'm doing db dot and then I give it the collection name. So I'm not using like a key like we would in a dictionary, but I am referring to the actual name of the item that I'm referring to. Here it's a collection. Up here it is the name of the database. And so this is going to get called as soon as Python becomes aware of DB APIs, which it did here. So when it becomes aware of this, it's going to go to DB APIs. In DB APIs, it's going to import DB. And at that point, it goes out and it creates this client. It does this the first time, and then it uses that from that point forward. And it creates this database object. And now I have my database object. Now, in DB APIs, I can say db.hosts.find in order to get them. I can do find one, insert one, update one, etc. So all of this is possible because of this wonderful library called PyMongo that makes it very easy for us to deal with Mongo databases. Now what I'm going to show you is I'm going to actually delete tables in the database, and then I'm going to start all of my code running, and you're going to see that I didn't need to create anything. It creates it automatically. So let's take a look at that. First, I'm going to shut down my monitor stuff. So now it shut down all of my 4 monitoring applications. And now I'm going to come up here and actually what I'm going to do is I'm going to do this gracefully. I'm going to shut that down so that I don't end up with ugly stack traces, exception traces. I'm shutting those down. Now I'm going to shut down my Mongo server. So now my Mongo server is shut down. What I'm going to do next is I'm going to go to Mongo. So here is where I'm going to run Mongo. The way that I run the CLI in Mongo is I just say Mongo. It puts me into the Mongo shell, and now I need to tell it to use my database. So I'm going to say use QuokkaDB. So now it's saying it switched to QuokkaDB. I'm going to say show tables, and it shows me that I have devices and hosts and services. Those are my 3 tables. So what I'm going to do is I'm going to drop those, and I've done that recently. So I'm going to drop services. I'm going to drop devices, and I'm going to drop hosts. So now if I do show tables, you can see I actually have no tables whatsoever in my database. And now I'm going to start my Quokka server. This is the command that I'm using. Somebody asked me, why am I using port 5001? Why have I changed to be using that? The reason is that I have been running Quokka, the real application that I built a while ago. I've been running that in addition to these little coding examples, and my coding examples are now using Flask also. And by default, Quokka is using 5000. That's the default port, so I'm using 5001. That's why I'm doing that. And of course, I have to, this is a Flask thing, tell it the name of the actual Python module that I want it to run. So it has started. Now it has started. If we were doing SQL, then when I showed the tables would show up. But I'm going down here to say show tables, and there are still no tables in my database. And in fact, I'm going to run hosts. You can see it didn't crash. It actually was successful and just returned nothing. These GET requests happened and it just returned nothing. And let's see if it has created the tables yet. I'm going to do show tables again, and there are no tables. Now I'm going to run these monitor programs. Remember, these monitor programs are going out into the network, and it's discovering hosts, it's communicating with devices and services, and it's updating these things. So let's see what happens when I run this. I'm going to run to monitor all. I've created a script to do that. It runs all 4 of these. And now it's going out into the world, discovering those things. And now if I do show tables, you can see I have my devices table, host table, and my services table. So this is the nice thing, once again, about Mongo, and specifically about these NoSQL databases. They are very flexible. One other thing I do want to point out, and this is more of an advanced thing, with SQL, if you have a database full of data and you make a change to your schema, to a table, to columns in a table, you are going to have to write migration code to migrate from the previous schema to the new schema. And that, I can tell you, having done this for the better part of 25 years or so, is a very, very difficult task. And people have written software to help facilitate that process, but it's very, very difficult in SQL. In NoSQL, it's no problem. Why? Because remember, if I do db.host, let's do devices, let's do services, services.find, parentheses. Remember, this is all just JSON data. If you want to add a column, what happens? You just have more data in here. Now, one thing that is true is you need to be able to deal with that, and I'll show you the code where I deal with that in just a second. I did have to make a change to the display because some of these displays, before things get, before my port scanner actually runs, and you can see the port scan is it takes a very long time to go through everything, right? So you can see it's beginning to slowly add this data because I blew away everything. In the absence of that data, you don't get anything back from the database. So my code, which normally was just trying to reference a host with a key of the open TCP ports, if I didn't get anything back from the database, that would cause my Python program to crash. So I had to add something to deal with that. So I'll show that to you next. But the main thing that I wanted to do and communicate with you in this situation is, here's how you set up your database. Pretty straightforward. You end up with this thing called DB, and over here in DB APIs, this is how we refer to it. The database dot the collection. I keep wanting to call it a table because I'm used SQL my whole life. It's a collection, and then the actual method or function that you're attempting to run against it. Okay, so let's look at how we need to adjust to the fact that we may be getting incomplete data back. In other words, we may not be getting all of the things. Here's my print statement where I'm attempting to print out all this stuff for hosts, and I'm expecting there to be a key called host name and a key called IP address and a key called MAC address and availability and last heard and open TC ports for every host that I am attempting to print, so that I can be printing out this nice data right here. Now, as you know, with Mongo type data, and for any NoSQL database, the data that is in the document, a document being the effectively row or line in the collection that has data in it, For each one of those, the data is represented using what? Using JSON data. And so with JSON data, there can be fields or data items that actually are not present. And if we have a host for which some of the data is not present, then when I try to print this out, it's actually going to fail and it will cause an exception. And I don't want that to happen. I want it to just print a blank. And so what I do before I print it out is I created a little function that just goes through here and it actually sets missing fields. So I say for field name in, now this is the list of all of my field names. I need to make sure that these match the things that are down there. If you've remember when I talked about using constants, might be a good idea for me to be using constants in a real application, but I'm not here, so hopefully I spelled all of these correct. If the field name is not in this host, so I'm being given this host, if the field isn't there, then I create it by using normal Python dictionary stuff. I pass in the field name, so if it doesn't have open TCP ports, let's say that that's not run at all, so there's no data there, then it will say host with a key of open TCP ports equals just blank. And so for these that have nothing, well, they all have, this one actually doesn't have anything in it, this one up here, because we can't talk to it yet. So you can see we're not getting anything back for that data, then it's just printing a string with no data in it, this thing right here. So the upside of flexibility is you don't have to worry about data migration, and it's way easier to set things up because basically you don't have to set them up. The actual calls are pretty straightforward. The way that you reference things, if it's not there, it will create it. The data that you write to it will be written in JSON format, so you don't have to worry about columns and all the other nasty stuff, and it's very easy to declare it as we've seen here. The downside is that if you are getting different data back that may be missing fields in it, in that JSON data, then you need to make allowances for that. And this is an example of one such thing. Hopefully that makes sense. As you see, I just started this a while ago in our last little segment in this lesson, and you can see it's begun to fill in all of these OpenTC ports as it finishes scanning all the devices. So there you go. That's the use of Mongo in our Mini-quokka application. All right, let's quickly remind ourselves what we talked about in this lesson. We're talking about moving data from these global internal data structures, in-memory data structures, into a database. We've done that with SQL. Now we are looking at NoSQL database type, and that is Mongo that we'll be using. It is not restricted to having a predefined schema and predefined tables and columns, but rather it's flexible. The tables are called collections, the rows are called documents, and the data in the different columns is just captured in JSON fields. So it's all JSON data that is stored, and we looked a little bit at that just to remind ourselves. This is kind of hard to see, but if I highlight it there, maybe you can see that's just regular JSON data with a key and a colon sign and then the value associated with it. We looked at the code for this lesson, and we saw that my Mini-quokka package only has these three modules in it. That's because everything else is common and could be shared by multiple databases, and so we moved them out of this particular area. We could have done the same things with SQL, but we hadn't done that yet. So SQL could in fact use these functions because it's just the display in the monitor. If we look back at this picture and we remind ourselves what this looks like, everything that's external to our application can actually be independent entirely of any of the changes that we make in the back end because we have this nice REST API. So that's what we talked about. We looked at the difference between the Quokka server and SQL. Here, if you look for the initialization of the database, you'll see that we don't have any. We don't have to do that. We looked at these endpoint functions that handle things like getting of hosts and putting of hosts, and we saw that it was exactly the same as it is this part anyway, as it was for SQL. The reason is because we created these nice API functions that allow us to be shielded in this code from the changes to the database. And all we need is different DB API code. So our DB API code that we have for Mongo is pretty straightforward and it's pretty simple. We notice that the way that we reference the database is we use this thing called DB, which is defined in extensions, as you can see there. We do db.host. We refer to the table in that way. Services, we would do it with services. We do a find to get everything. We do a find one to get one, and we pass in what we are searching for. In our case, it's the host name. And if we didn't find it, then we insert something into the database collection. And if we did find it, then we update it. And so this is the nice, easy thing. It just allows us, even if host has not been defined, even if the row is not defined, then it will create it for us. So that is the wonderful thing about how that works. One of the last things that we talked about was the fact that the downside of having all this flexibility is the data that we get back in terms of this. I did this get hosts, and I'm returning all of the hosts. And the downside is that we may not have all of this data there and ready for me to use, and therefore, if I try to reference the IP address, or MAC address may be a better example, and it's not there in the data, this will cause my program to crash. So what I did was I set the missing fields, and here you can see me doing that. If the field is not there, then I just set the value to an empty string. And that's what we talked about. Hopefully that made sense. As always, and I mean this, send me questions in the YouTube comments or wherever you happen to look at it, or on Twitter. I'm happy to answer those questions. I hope you see that this is easier than SQL, and that, yeah, this may be the spot where you want to dip your toes into the pool of getting your feet wet with databases. And hopefully it will be of use to you in your Python programming exploits in the future. Thanks for listening.